This is actually a really fun topic for us. It's activity-specific prostheses. The name activity-specific was probably coined back in the 2000s. People would refer to the devices as sports and recreational, but beyond that, they were a lot broader than that. So activity-specific became the kind of the nomenclature that was adopted, and it can cover, activity-specific covers many different kinds of things.
Yeah, from sports and recreation to all different kinds of leisure time activities, photography and the arts, musical instruments, and we're going to talk a little bit about these. But before I do, and I'm kind of throwing a bomb in there, but this is a really important topic right now, because right now we have an initiative in practically every state in our country that speaks to movement for all. And what does that mean? When we think about movement for all, oftentimes people think about persons with lower limb absence and being able to access different kinds of environments and activities. So making things accessible. But that also includes those of us with upper limb absence to be able to have more than one prosthesis. Because believe it or not, there are still areas where persons can only access one prosthesis for life. I mean, think about that for a minute. I was born with a congenital limb difference. I have prosthetic arms that my parents saved. I often joke that some parents save their kids' shoes and have them bronzed. My mom and dad saved my arms. And I have this collection. I don't know what I'll do with it someday, but my point is I've never had to have that choice of when do I have my prosthesis? When do I get that one prosthesis? I have a series so that as I grew, I could learn to use it and engage in different kinds of technology. All of that has spoken to the opportunity for me to be able to engage in very diverse activities. And that's what activity-specific devices can do for the upper limb population, whether it's through actual absence or loss, or persons with loss of functional, but still a hand on the end of their arm.
So you have to talk a little bit about the origins of what were activity-specific prostheses. Prostheses themselves, body power, they evolved after World War II in Korea. People were coming back from the military and they needed functional devices. So they were thinking about how do they get people back to work, how to handle domestic and things, and work tasks. So people weren't thinking about sports and recreation at that time. But in the 50s, there were two devices out there. One was called it was a device for sliding into a first baseman's glove. So it was a baseball glove adapter. And the other thing that was developed by a company called Hosmer Dorrance was a bowling ball adapter. Those were about the only two recreational or activity-specific devices that existed into the early 50s and 60s. After I became, when I was in an accident in 1971, I became an amputee. There were other things I wanted to do, and one of the things I did a lot, I played soccer. So the first concept of an activity-specific device that I started to conceive of was a device that would help me with soccer. And so what we slowly evolved into was a device that I created called the Super Sport. So here we have Super Sports and Free Flex devices, and you can see in the upper picture the way that the Super Sport captures the ball. And I just have, they come in different sizes and colors for different ages and groups. It was just a simple, but what you have to realize, this is a very flexible device. The reason this was able to be conceived is because there was a certain type of polyurethane rubber that was available to us that we were able to mold these out of. So this has no internal skeleton at all. It's cast out of a one piece of very proprietary polyurethane. But it acts a lot like a human hand. It flexes and extends, and it has resiliency. It has elasticity to it. So it operates a lot like a normal hand. I can actually do a handstand, or I used to be able to do a handstand on using one of those devices. So that was the origin, one of the origins in the 70s, the evolution of activity specific. As we moved on a little bit, and we had better molding capabilities. You can see in the bottom It's a super sport, but we called it we changed it, gave it some anatomical features, and we called these free flex hands for people who wanted something that was a little bit more anatomically correct, but had all the features of a super sport kind of a device. What are some of the other things that evolved activity specific wise? Well, there's an interesting story here. We call a volleyball device called a barrage. So I had a young man, his mom contacted me. This was going back maybe 10 years or so. And her son was in high school, he wanted to play volleyball. And I talked to him about the super sport and the free flex hands. Wasn't quite meeting his needs. He wanted something that he felt was more specifically appropriate to volleyball. So I asked him if they wanted me to take on that project, and I said, well, I would do it, but I wanted a commitment from the family to provide us with feedback, because these kind of projects take months and months to do sometimes, and you have to build prototypes, and they have to be tested. And I wasn't an avid volleyball player, but I had played volleyball, so I needed someone who was going to give us feedback. So we engaged in this project. And the interesting thing about the barrage, and I don't believe I have one here, the barrage had to replicate some really unusual hand positions without having to flex and extend, because it just wasn't feasible to quickly change your terminal device position when you're playing volleyball. So it had to replicate the ability to set the ball with your fingertips without having fingertips, and it had to be able to be used for bumping and all the kinds of things, blocking that you did in volleyball.
Right, so you needed a hand open as well as tip, and you needed that whole kind of fist bump.
Exactly. So we worked on a couple designs, and the barrage is a very flexible device, and it actually allowed people to perform volleyball and play competitively, because it was able to duplicate those anatomical aspects, functional aspects of the hand for volleyball. So as time went on, there was more and more of a demand for different types of devices, and as you might imagine, golf is a very, very popular sport, and so early on there have been a number, just a wide variety of golf devices. Most of them are individually custom made by prosthetists or machinists, and then we began to actually develop some really reliable manufacturable versions of devices to play golf, and this is some examples behind us of what these are, Golf Pros, and there's just any number of different ones. We wound up meeting a gentleman who came to us who had been in Vietnam, and he had lost his hand. His name was Tom Willard, and Tom came to us with a design that he had. It was called the amputee golf grip. And the amputee golf grip, I'm not sure, I don't even think I have a picture of it here. Let me go forth with another slide. I do not. But the amputee golf grip was a device that he had designed for himself and put into production, and it was allowing him to play golf as a unilateral golfer. And it worked very well. So we took that on, and we built that device for probably 10 years for him. And then other types of golf devices evolved. One of the earliest ones was a company called Robin Aids in California. And actually Tom Willard's amputee golf grip had a lot of parallels to that. There's another device in Canada called a Trotman golf device, the Trotman golf device, that has those same attributes. It's kind of a stem that fits around the golf club grip, and then it has a flexible coupling which helps to replicate some of the biomechanics you need in swinging a golf club. So swinging left-handed, there's just different nuances. Whether you use the leading arm to attach to the golf club, and that's your leading arm would be your prosthesis, or the trailing arm, there are nuances to how that device has to be made to give you the best performance. So if you're missing a hand like I am on the left side and you swing right-handed, we have a different style and design device than if I was missing my right hand and swung right-handed. Debi swings left-handed, so she puts her leading arm is actually her right arm, and she trails with her anatomical arm. But so when you're playing golf, it's a little bit of a process in trying to select what might be the best device for you. And a lot of these devices are adjustable; they can be changed in durometer and strength and things like that to accommodate different people's needs. Again, back in the evolution of activity-specific devices, we have the AmpuPod. So the AmpuPod was a very simple device for holding what were traditional 35mm cameras and video cameras. And I have an interesting story. This came into existence in the 1980s. A fellow named Craig Bailey, who was a graphics designer who had been in an accident and wound up having to have his hand amputated, was wearing a split hook prosthesis. And being a graphic designer and photography, he came to me very frustrated one time. He lived in Denver, and he had dropped his Nikon off a bridge. not being able to adequately handle it with his prosthesis. And he said to us, he had got to be a better way. And so we developed a very simple tripod top, adjustable, lockable tripod system and put a camera on it. Worked really well, and we've made the AmpuPod's been made since the 1980s, and it satisfies the needs for those people who still want to carry a more traditional type camera and have it on the end of their arm for stability. And it's just a fun little device. It's met the needs for a lot of different people out there. As other things evolved, just sharing with you lots of different designs. We have this one. This is called the Hustler. The Hustler was designed for playing pool and billiards, and Deb can tell you about the top one. And there's a difference between the two. The bottom one actually is the newest version.
So that the top one can go on my activity-specific device, and it gets adjusted. I'm going to give you the simplified version of it. But you can see there's that white ring, and that's where you can put your cue through that so that you can stabilize it and then use your hand to help to manage however you want. So some people will want to go this way and kind of guide it and then thrust with their prosthetic side, or you can have the cue in the ring and then you can use your intact hand. Depends on how you like to use it.
And the version on the bottom is just a lot of these products are changing the way they're being manufactured, and so the version on the bottom is the newest version of the AmpuPod. It's replaced the upper version. It's being made completely. You've heard of 3D printing and additive manufacturing. The Hustler now is being manufactured with additive manufacturing techniques, which allows us to make it lighter, a little bit more stylized, and still maintain all the strength and functional characteristics that it has. So musical instrument adapters, these have been around for quite a while in different forms. We have one for guitar pick, for violin, and for drumming. So what initiated this was, I had a family from Fort Collins, Colorado, and a lovely young girl named Mary Frances, who was at the time probably, I think, maybe 8 or 9 years old, and she wanted to play the violin. And there was no devices out there really anyone had conceived of, or really trying to produce a prosthetics device to handle a violin. So her parents came down and met with me, and I said, well, let's take this on, let's see what we can figure out. And we had been using those little lockable ball socket. And we figured out a way that we could build a violin adapter that would grasp onto the violin bow and give her the kind of control that she needed to actually play a violin. So it's nice because it was a consumer conceived type of device.
Oh, right.
That coming to the company that I owned at the time, and us taking on the challenge, and we've done that a lot. A lot of the activity-specific devices that we've developed over the years, although we've developed them through various companies, they were inspired or thought of or conceived of by consumers themselves. They're consumer-driven. So get into a different kind of activity that we're talking about, and people enjoy swimming. And I always kind of kid people. I said, people with that are missing a hand don't necessarily swim in circles. They can compensate. So that's not an issue. But you want to have, if you want to swim with higher performance, it's very useful to have some type of either a swim fin adapter that can fit onto your arm, or actually a custom swimming prosthesis. And so we were challenged many years ago. A fellow named Robert Debi came to me. This was back again probably in the late 80s, 90s. Robert was a very qualified CPO, certified prosthetist orthotist from Canada. And he had been working with a patient who wanted to swim. And so he had conceived of a sort of a 4-finger type of a terminal device that had little valves, fins in between the 4 fingers. So as you pulled it through the water, they would open up, and as you tried to retrieve your hand, they would close up and give you resistance. And that's important because many people, swimming requires, if you think about swimming in like an Australian crawl, you have to be able to feather your hand in the water, or you have resistance in all directions, and it's not conducive to very good swimming. In fact, you can flounder in the water. So Robert conceived of this device that eliminated the need to pronate and supinate by having these valves that operated. Well, I looked at his patent and such, and it was a brilliant idea, but it was very difficult to make. It had 4 fingers, it had all these little valve fins in between. And so I looked at it, and we were able to say, well, why can't we just make this into a butterfly wing? This is a folding fin, and it collapses under the water's load when you're retrieving your hand, and then it flares open in the power stroke. This is called a freestyle, and it's been around for a long time, and it's very functional. So we took we took Robert Gabriel's design and turned it into something much simpler. And the beauty behind doing it this way was that you could cut it down. The prosthetists could take this and they could make it smaller. They could cut it down to half this size. So it could match the displacement, of the hand. So if it was an adult hand like mine, that matches my displacement. If it was a smaller hand, it could be trimmed down accordingly. Now, if you didn't want to use a prosthesis, then the alternative was to use something like, to put it directly on the end of your arm, and it can give you the ability to push more water and perform better in the water and get resistance. So it's we called it initially a therapeutic swimming device because it can be used for shoulder rehabilitation. For someone who has a shoulder injury that also involves the loss of a limb, then you can put this on and you can work out with a physical therapist in the water and help strengthen the muscles of your shoulder and that type of thing.
Yeah, another thing it's great for is because it gives that kind of proprioceptive feedback to the user. If it's someone who wants to be able to swim in a straight line, because think about it, when we go in the water, we're not wearing a device. One arm is a lot longer and stronger than the other side, and we end up going in a circle. Well, at least I did. You're probably, but wearing a device like this helps to give me that feedback so that I could learn to swim in a straight line. Yeah, that's.
And if you want performance swimming, then a short sports prosthesis is really what you need. And there's an example of one on the screen behind us now. This was built by a gentleman named Randy Alley, and it has kind of a quasi, what they call a hi-fi suspension to it, so it fits very intimately on my arm. Water is a lubricant, so when you're wearing a prosthesis in the water, it has a tendency to come off. So you need a specialized prosthesis, one that either uses a roll-on locking liner like Debi described, or a prosthesis like Randy built for me. So it's a short sports prosthesis. So why is it short? Bringing that paddle, bringing that resistance closer to the end of your arm gives you better control over it, makes you a better swimmer, gives you a higher performance, and the leverage works because the resistance of swimming works against your arm. It's a lot more comfortable than trying to put that paddle out a long distance. I'm pretty short. If I put the paddle out here, it would be a lot of resistance, difficult to control. Bring the paddle into mid-forearm like it's shown on this, and I have a lot better ability to control it and swim a lot better with it. So that's a short sports prosthesis is really, if you want to do a lot of performance swimming, then recommend looking into a short sports prosthesis.
Yeah, that's a good idea. I'm seeing a lot of trends here. So I see the idea of listening to and hearing what the end users have to say about their experiences and what their needs are and helping to solve problems. But then I am also hearing a trend here with your understanding of both materials as well as biomechanics. So how have biomechanics spoken more into some of the evolution of these devices?
It's been very important, and luckily, as I said, my past was I grew up in the 50s, and I was able to participate in all kinds of activities when I was a young kid. Baseball, football, I did pretty much expose myself to all kinds of things, and so I understood what it took to swing a baseball bat or to handle a hockey stick or to swim. So it gave me an ability to have that insight in. When we started to design some of these activity devices, I knew what it would feel like, and I could test them. The beauty of it was that I could test them on myself and make sure that they worked. So it allowed us to move forth very quickly with a lot of these designs because I was actually I understood what was needed. We were able to create prototypes, test them, modify them as needed, and get them to a point where they really work pretty well and make people competitive. So on the slide behind us is just some other examples of some short prostheses and alternatives. The gentleman in the middle became a very good friend of mine. His name was Joe Thompson, and you can see this large fin-like whale fin that he designed. He lived in Hawaii. Joe survived a very, very severe shark attack when he was a younger man. But he was an avid outdoorsman, and it didn't stop him from going back in the ocean. And he was a colleague of ours for a long time in helping us develop some of these swimming devices. A fellow Cameron up in the upper left-hand corner was actually underwent a severe accident and actually was missing 3 of his limbs. But he was able to use, he was an avid surfer as well. He was able to use the swim fin to be able to get back to trying to get to be surfing and stuff. And then in the bottom right-hand corner is a different device. It's called a Kahuna. And the Kahuna was conceived for people who were primarily wanting to surf. It was a flexible paddle, and in fact, the lady who helped me develop that.
Right, Amy Ginsberg.
Amy Ginsberg, and Amy at the time, before you got to know her, was working in Southern California with a group of Navy, I believe they had been SEALs or they were Navy veterans, and they wanted to surf, and so she contacted me and said we would need to have a surfing device. And so the Kahuna evolved over a couple years. The first one we built was a little too big for people, so it got reduced in size, but Amy Ginsberg was one of the reasons that device came into existence.
Oftentimes, when we're engaged in sports, we need to be able to rotate, to be able to turn our hand. We often do that with forearm pronation and supination, which comes from the forearm area. So when we're engaged with activities and using devices, having something that can kind of work both ways, but we can't turn, can be a challenge. Not everyone has a wrist rotator or anything like that in their wrist, or they have to manually rotate, and that can be problematic. So the high fly is kind of cool because it's basically a net. It's like a lacrosse net, right?
Works bi-directionally.
And it can work both, correct. It works both ways, bi-directionally, so that it eliminates the need for pronation and supination.
Yeah, when you play baseball, and I played a lot of baseball when I was a kid, if you're catching a ball below your waist, you rotate your hand down like this. So your hand is basically facing down. When you're catching a ball above the waist, you pronate your hand upwards. So you use pronation and supination. Well, if you're playing second base, if you're an amputee or someone who's using a prosthesis, you're playing second base or your shortstop, you have a line drive come at you. You have a second to react. And so you have to spontaneously be able to put your glove up, or in this case, the high fly. Right. And you don't have time to think about turning your device on it. You have to react spontaneously. So the high fly solved the pronation supination problem by having a bidirectional pocket. Simple idea, and it's actually made with a lacrosse stick head. That's actually off a lacrosse stick. We worked with a company called STX that was able to sell those to us and modify them so that we could create this baseball catching device. And it has all of the regulatory features of a glove. It has to do with how much square inches of catching surface you can have. So it's been used successfully for many, many, many years. So how did basketball devices, activity-specific devices, come into existence? Well, we had the Super Sport originally, and that was used and designed for trying to, use. I played basketball with it myself. Well, we had a young man that I got to meet. His name was Will Mills, and his family lived in the North Denver area. And Will had been in an accident. He was in high school, and he wound up having an amputation at his wrist. And he was an avid basketball player, really good. He was also a water skier. Well, his mom was a physical therapy assistant, and she was familiar with materials that are soft, flexible, moldable plastics, and they call them aquaplast or orthoplast. They're splinting materials, and that's what they had available. So they took his hand, or they drape molded this material over a basketball, and he was off at the wrist. So and then they cut it out, and it's shaped kind of like this, and they ace bandaged it to his forearm, and they put padding on it, and they tried to reinforce it, and they created this cup-shaped device that they had, and Will was teaching himself to play basketball with it, and it worked very, very well. Trouble is, the materials were ineffective, and it would break about every 2 weeks, so it didn't have any integrity. So they came to us and they said, "Can you help us, take this, bring this, develop this into something that's more functional?" And it took Tony Asnikar and myself probably almost a year to figure it out, because it had real thin cross sections. We just couldn't mold it very well. It was very difficult to figure out. But we finally solved the issue, and we created it. And the deal was that we would make these for him, custom ones, and in return, because it wasn't something we patented or anything, and something they didn't want to patent, and they would let us make them in a different version for people to be able to put them right on the end of a prosthesis. Will wasn't wearing a prosthesis. He was just taping them to his forearm, kind of like an orthosis or a prosthesis. So we conceived of the Will Mills Rebound basketball. terminal device, and so that's how it evolved, and
Really
it was
cool.
amazing. He could dribble between his legs, do all kinds of shots with it, and he went back to playing, and he became captain of his basketball team the year we got it for him, which
That's
was
incredible.
a nice rewarding story.
That's great. What about the Hoopster? So the Hoopster is a totally different kind of device, and I have a feeling that you have another story that relates to the Hoopster.
It is. It's also a fun story, and it has to do with products that were conceived of and driven by people who are amputee consumers. So Hector Picard was a fellow that was a lineman. He'd been an electrical lineman, been in a horrible electrical accident, and had lost both of his arms in a severe high voltage accident. He had lost his left arm close to the shoulder and his right arm long transradial, long below elbow. But he was a young father. He had 2 5- and 6-year-old sons. He wanted to be able to play basketball with his sons and play baseball. And I got to meet him in Denver. He was at a Skills for Life conference, which was a conference oriented toward people with bilateral hand absence. And I met him there, and he demonstrated this device that he had made. And he had conceived, Hector Picard was his name, and he had taken the bottom of a galvanized pail, that stiff rim, and he'd cut it out. He was a handy fellow, even with no hands, so to speak. And he'd taken that, put a welded stud to it, wrapped bicycle inner tube around it. So he had this steel hoop with bicycle inner tube around it, and he taught himself to play basketball one-handed because he had no other left arm. And it worked really well, and he could do layups with it, he could do all kinds of shooting with it, dribble with it, everything just with one hand. I was really impressed with it, and I said, Hector, can I work with you? I'd like to take this to market and help you with it, bring it out so that other people could use it. And he agreed to that, and again, it took probably onwards 9 months or a year. We took on the project. We actually incorporated, used an industrial, a vocational school in Longmont, Colorado to help us take the design into a CAD model. So I involved some students in the project, and I told them, I said, if they could help us with the CAD model, I would bring back to them a fully completed product within 6 months. They didn't believe it, but within 6 months we came back with the Hoopster, and Hector helped us develop it. He continued to work with us. We made him in different hardnesses. It's a flexible rubber hoop. I told Hector we couldn't make it out of metal because we'd wind up getting some severe liability. So we made it cast it in polyurethane, and it's been successful. And he helped us tune it up as to the kind of material we had. We added a wrist angulation lockable thing so you could tune it to exactly how you wanted it to be on the end of your arm. And we introduced it, and we paid Hector royalties for 10 years for contributing to that design. So.
We've talked a lot about these different devices and the stories that are associated with them. And over again, I'm hearing, and I know I myself have experienced it firsthand as a user, but also as an occupational therapist and working with this population, how much empowerment there is. But hearing this story makes me think also about how you're empowering potentially other manufacturers to be. I wonder how many of those young persons who were in that CAD class and did that assignment, took it on, I wonder how many of them may have become biomedical engineers or maybe working in the industry. Sure. And then I think about how many times both of us have been contacted by engineering and OT students with ideas, and and even in the fashion industry, there was a university that contacted both of us about that. But just how much we've spoken into that kind of empowerment too, that hopefully comes back to bless us as consumers with new idea changes and opportunities. So I think this is really cool. I love hearing these stories.
So let's get back to a slightly different activity. Let's talk about some baseball and softball. So one of the challenges with swinging a baseball bat is getting on and off the bat quickly, certainly, but having the biomechanics to be able to swing a bat smoothly. It relates to the same kind of thing with golf. Replicating the biomechanics to allow you to have a nice, smooth, powerful swing. Mm-hmm. And the reason that these devices were initially conceived was because of the material called polyurethane. When we started to use polyurethane in manufacturing, it opened up all kinds of design possibilities to us, because polyurethane, if it's custom formulated, can be created to be stiff, can be soft, and depending on how you design it, you can replicate functional biomechanics of human biomechanics in a synthetic polymer. And so we were able to develop became the pinch hitter and the Grand Slam. These were devices that would simply clamp on and off, quickly attach and release from baseball bats, but give you the ability to have a really strong, complete swing. And I remember way back, because we developed these back started to develop these in the 1990s and the 2000s, what it felt like to swing a bat two-handed for me for the first time again. And I grew up, I was ambidextrous. I threw a ball lefty, but I swung right-handed. And so putting the prosthesis on my left side and being able to clasp that bat and being able to hit a ball two-armed again was just exhilarating. It was exhilarating, and I could do it better, certainly, than playing one-handed. So anyway, these devices have evolved. There's some just examples behind us of what these swinging these different kind of baseball and softball devices will look like. So another part of the story, as I just had described, I was a southpaw. I was pretty lucky. When I grew up, I was in the Little League when I was 11 and 12 years old, and when I was 12 years old, I actually got to go to the World Series. We didn't win the World Series, but in 1961, I was in the World Series in Pennsylvania. So when I lost my hand when I was 21, and I used to throw a ball left-handed, I was a center fielder. I had a pretty strong arm and was pretty proud of my ability to play baseball. So when I was 22 years old and I was in a car accident, crushed my arm, I couldn't throw a baseball left-handed anymore. And I started to try to learn to throw right-handed and such. And I never could quite get my ability back the way I thought I could throwing baseball left-handed. So it was many, many years later when we started to develop the hoopster that spurred my thoughts to whether could I make a small hoopster that might help me control a baseball. So that the hoopster can help me drive towards the concept of developing what became the Cobra. And the Cobra is a multi-part device. We conceived of it. I thought about the Cobra. I came up with the idea of a cup and a flexible arm. We tried to make the Cobra in one piece. And when I first molded it, I would put it on the end of my arm and I would throw a ball and would go straight into the ground. I had no way to control the trajectory of the ball. So we realized that it needed adjustable wrist. It had to have a flexible section that replicated, the kind of wrist motion and action. But then it had to have a cup that captured the baseball or the softball, and that cup had to be able to change and locked into particular orientation so that when you threw the ball, you could control and lock in the trajectory. And then once you locked it in, your hand-eye coordination, my hand and eye coordination came back, and I was able to throw a ball instinctively, just like I could when I was a young man. So it was a neat device. It's one of the things I'm most proud of as far as its development, because I was throwing a ball at close to 50 miles an hour accurately, and I could throw a ball in, probably 80, 90 yards. Again, and it was very, very rewarding. So we evolved it into being able to use it for softball as well, and we were actually able to practice with like a fast pitch underhand as well, and because it was so tunable.
That's very cool. I have a story about the Cobra that hopefully I can tell it without crying, because this was a gentleman who was very dear to my heart. He was middle-aged and had survived cancer, but in surviving cancer, he lost all 4 limbs. He had also gone septic during some of his treatment. So he ended up losing both arms, both hands, and both legs. And I saw him through Handspring, the practice that I collaborate with, and they fitted him with lower limbs, and we also fit him with upper limb prosthetic technology. And this man had 2 sons, and he wanted desperately to play ball with his sons. And he had been, but it was before you developed the Cobra, and he was holding on to a laundry basket, and he would try to catch the balls that his kids threw. Well, then you came out with the Cobra, and we were able to access it for him. And we fit him with it, with his device, and he brought it to his physical therapy appointments 3 times a week for probably about 8 weeks, because he so desperately wanted to learn to use that device and be able to surprise his sons on Father's Day, which was about 2 months away from that point. And so he did this, and he sent me a video of the whole event where he was having breakfast with his kids, and there was a short clip, and his son said to him, "Dad, what would you like to do today?" And he said, "Let's go outside and play ball." And the boys did not want to do that because their experience playing ball with their dad was that they'd be chasing the ball, right? Because their dad couldn't really throw it and he couldn't really catch it that well, as far as they knew. But then he talked them into going outside with him, and he used the Cobra, and they were amazed. And he told me that it was his best Father's Day experience ever. Well, unfortunately, about 3 or 4 months after that, he passed away. And his sons reached out to me and told me that that experience of playing catch with their dad on Father's Day was cathartic for them as well, and that was one of their best memories of their dad.
That's a great story.
Yeah.
Great story. So moving on, as activity devices continue to evolve and change, some other new stories, a great amount of stories, consumer-driven prosthetic concepts came out. And so the gentleman in the left-hand corner of the screen that you can see, his name's Mike Hummel. And I not met Mike personally, but Mike called me many years ago. We're going back probably 15 years. And Mike had been, he was a semi-pro bodybuilder, and he had been in a horrible car accident, and he crushed his lower forearm on his left side and was equipped with a prosthesis. And he was wearing, at the time, was using one of our all-metal grip 2s. And he had modified it so he could lock around it. But it wasn't giving him the kind of stability on the barbells that he needed for the kind of weight that he was dealing with. So I talked to him on the phone, and he was asking me whether or not we might be able to improve on the device. And I said to him, well, Mike, I'm in the gym, you know, I lift a little bit of weight. I said, what kind of weight are you dealing with? And he goes, well, I can't break 500 pounds. And I kind of gulped on the phone. I didn't know people could humanly bench press 500 pounds. And he said, yeah, pro bodybuilders and wrestlers and some football players, they'll push that kind of weight. And he said, well, can you help me out? And I said, well, I need to think about it. Let me get back to you in a couple of days. So Tony Asnikar and myself got together. We started to research out things. We found this forged aluminum clamp that was used in industrial buildings to hang pipe from ceilings. And we bought one. We figured, well, maybe we could mess with this. And it was gigantic, and we ground on it and modified it, and we built padding for it. And it became what we called the Black Iron Master.
Wow.
And we made one, and we figured out how to put it on the end of his arm. And we sent it to him. He got real excited about it, started to get back into regular bodybuilding again. And he won after about 2 years of really working out. He went in and he won the world championships in bodybuilding in his weight class. He weighed about 235, 240, and he benched 660 pounds. And he did it with a Black Iron Master. And so it was a great experience for him, and it was tremendously fulfilling for us for giving him the kind of ability to do that.
Can you show that other one too? Is there a Black Iron Light?
This is the Black Iron Light.
Yeah, this is more my speed, probably.
The Black Iron Light is also being changed now to additive design, but we can make this in different colors. A little lighter weight. It's designed for lightweight physically, but designed for lighter weight. Mostly aerobic type dumbbells and things, 10, 15 pound dumbbells, but kind of a little cooler looking, fits on the end of your arm, fits onto a regular system wrist or a disconnect wrist, and just another alternative. We see people, using this as an alternative who don't need such a heavy duty type of weightlifting device. Now I wanted to mention others too. There's Texas Assistive Devices has an alternative type weightlifting device, and I wanted to share those with you. You can see them on the screen behind us, and those are ratchet type of devices. So they snap around and ratchet around dumbbells and barbells. So there are some other alternatives out there, and these are designed to fit onto a regular prosthesis, and also custom designed to fit onto. Texas Assistive Device has their own mounting system on prosthesis as well. So what you're seeing behind us is systems designed, two devices designed to fit into their particular system, but they're also designed, they have alternative technology that fits onto a standard prosthetic wrist as well.
This is one of my favorites, the tumbler. One of the reasons I like using it, first of all, as an OT, working with young children, oftentimes with young children aged 4 to 6 months, about to get their first prosthesis. And that's an exciting time, because when we think developmentally about what children are doing at that point. They're beginning to bring their hands to midline and kind of finger them. They may be starting to learn to clap a little bit or even hold on to a cup. But more importantly, they're learning to sit upright. And when we're sitting upright, we have to be prepared for what might happen if we topple over. And it's great if we happen to topple over on our natural limb length side that's full length. But if we topple over onto our shorter limb side and we don't have a prosthesis on, we can't really catch ourselves. So having a short forearm prosthesis and a mushroom tumbler, the small version on the end for a young child, helps them to learn to be able to weight bear. They can use it for sitting, they can use it for crawling, and they can use it for those transitional movements in between, and even learning to climb up a couple of stairs. They can also use it to kind of pull at objects.
It's got good crossover.
So yeah, it's got a great crossover function. So I really like making sure that my young children who I treat and are involved with get one of these as well as one of the little infant hands.
So yeah, simple concept, works well. A lot of people use it for yoga. We've actually used this as one of its unusual crossover purposes. This, along with our Dragon terminal device, has been used for propelling wheelchairs. Mm-hmm. It's got really good control for pushing wheelchairs for people who are in chairs who have an arm prosthesis on.
Now this is my favorite.
The Dragon?
I love the Dragon, and that's what I like to use for well, I don't do martial arts, but for any kind of yoga or Pilates because of the unique contours of the device and the traction. I don't have to be concerned. Yeah, it doesn't matter if I'm on a mat or on a linoleum type of floor, wood floor with all that heavy poly that they have in gyms. So I really am prone to using the Dragon.
And you can't see it in the picture, but the Dragon is actually very flexible, so it's not a rigid, hard plastic. The little circle or hole you see in it is designed for shock absorption. So when we originally conceived of the Dragon, I was making it for someone who was wanting to work on a bag, punching, and doing martial arts, grappling, wrestling, and things like that. So this device is actually designed so that you can actually you can actually strike a solid object like a pole, and it absorbs all that energy so you don't hurt your arm. So it's designed for punching and grappling. It's tacky, it's got good frictional characteristic surfaces. And again, it's been used for a variety of other things like pushing wheelchairs and people using it for just general manipulation as well.
Pulling, you can use it for pulling.
Yeah.
I mean, I actually tried it out with a bar workout. So, they have these gyms that have bar exercises now, and they're mounted to the wall, and you can use that hook feature and it will support your weight. It's really pretty incredible what you can do with that device.
So the Swinger, great story about that. The little girl you see in the pictures behind us, her name is Sydney Howard, and she was from Southern California. And I got to meet her many, many years ago, virtually over the phone, her dad, and through pictures. And Sydney was just born congenitally missing her left hand. And she wanted to be a gymnast, and she wasn't going to let anything stop her. And she was one of the strongest little girls that I'd ever seen. At age 7 years old, she was able to do pull-ups. Little boys typically can't do pull-ups when they're 7 or 8 years old, but she was driven. And so her dad contacted us, and he wanted something that would allow her to do uneven parallel bars, which was a real challenge. So we developed ultimately what was the very, very first Swinger device, and that's one of them here in a blue turquoise color, and it was designed specifically to try to get onto uneven parallel bars. And Sydney was so good that we have video on YouTube on the TRS Prosthetics website with her using this on uneven parallel bars when she was about 8 or 9, 10 years old. She actually would grasp onto the low bar, swing up, do a forearm stand, swing up, stand on the low bar, jump through the air, capture the high bar, do have several hip circles, and dismount using this. We're in the process of redesigning it. The picture you can see on the screen behind me with the upper right-hand corner actually is a newer version of this that has a liner on it, and it's going to be additive manufactured. It'll be introduced this year. And then down below on the lower part of the screen, we're introducing a smaller version call it the Swinger Mini, for younger kids as well. So that adapts mostly for climbing jungle gym bars and things like that. It's not specific to uneven parallel bars. But working with her family, it took about 9 months to develop it back and forth, but it was one of those consumer-driven kind of projects that just I wouldn't have conceived with individually, but coming to us, it was a nice challenge, and we were able to develop something that hundreds and hundreds, maybe thousands of people at this point in time have taken advantage of.
Worldwide,
because of Sydney's interest and drive to be a gymnast.
Right, so it takes speaking up, it takes having someone who will listen to you and move forward with collaboration on development of an idea and trying it out. It's really pretty exciting.
Let's talk a little bit about an activity that a lot of people engage in, is that bicycling. Bicycling is a huge activity, recreationally, sport. Many people participate in it for just general pleasure, exercise, whatever it might be. And many years ago, I'd always said to people, if you want a bicycle, just use a prehensile or something like that. But as it turns out, people wanted something that was bicycle specific. They didn't want to deal with a cable. They wanted to have an activity-specific device that would clamp on and off handlebars. Initially, we conceived of what was some very simple devices. These were called Criterium, and they were designed, they're just flexible little rubber grabbers so that a person could snap these are just snap on and off handlebars. And we've made them in the past in a couple different sizes, different hardnesses, to meet the needs of people who maybe had a little bit higher performance needs, but primarily for road biking. They're not capable of off-road biking, mountain biking, and things like that. We'll talk about that in a little bit. But so the Criterium series, came into existence. You've had some experience with this, and it's interesting. There's some real interesting crossover aspects to devices like this.
Correct. And what gave me the idea for that, it was the whole idea that this device had a pivot action to it, so it could steer. And I started to think about what other tasks do we engage in, what other activities do we engage in that where steering is really important. And I immediately thought about steering a grocery cart, or a wheelbarrow, a baby stroller, all those functional activities that sometimes you just don't want to be wearing a cable-driven, harnessed device, or maybe if you use an electric device, it's heavier. So having an activity-specific device that we can use functionally increases its value. And the pivot action allows us to steer and gives it even more functional benefit.
So the Criterium have become very popular, and they've been used widely for many years. But as time went on, a few years back, I was working with that same girl, Sydney Howard, who had developed the Swinger around. Well, Sydney, besides moving past, once she moved past gymnastics, she got into BMX bicycle racing. She was she's a teenager. She's going to be 15, I think, now or so. But she had needs, and she was trying to use the Swinger on the handlebars of her BMX bicycle, and she was doing pretty good with it. But I realized it has certain limitations because it's not designed for bicycling, really. Sure. She was just effectively using it. So I decided to take on a project that she didn't know about it, and I decided to design a new type of device for bicycling that was more robust, that would meet her needs for BMX racing. And so we came up with what is now called a Criterium Plus. And this is a mechanical device. So this is actually has a series of springs that load this clasping or thumb portion so that you can push it around handlebars. It snaps on and off, has no lock. It's got a pivoting wrist component, so it allows you for a lot of biomechanical angulation of the elbow for comfort and control. But the Criterium Plus snaps on and off, very powerful, and it would withstand the kind of rugged use that you get from BMX biking, which I didn't have a lot of familiarity with. But we've also found that it's also used for certain kinds of low-powered motor vehicles and things like that. Originally conceived primarily for bicycling, road biking, BMX biking, things like that. But it's actually adaptable. It's capable of handling the larger diameter grips and things that you have on other types of like BMX bikes, mountain bikes, and things like that. So the we've been very successful with it, and that is also one of the unique devices that we have that has been not only machine manufactured, you can see the aluminum components, but the rest of it is all 3D printed. So all of the black material you see is all a very, very high strength nylon material that we've been able to print. So I wanted to share that with you. So what else with bicycling? Mountain biking is a little different animal. The Criterion Plus can be used with mountain biking, but there are some alternative devices as well. The Criterion Plus, that type of device, can be used for mountain biking, but we also had the ability to develop something that was really mountain bike specific, and this was called the Mountain Master. And the Mountain Master is kind of a unique device. Yeah, when you're dealing with vehicles, whether they be human powered like bicycles, or getting into motor vehicles where you're handling motorcycles or ATVs and things, I've always felt it important that you have an ability to instantly release. You don't want to lock on to any kind of a handlebar like that,
Sure.
because you could do yourself a lot of damage if the bike crashed or rolled or whatever it might be. So all of these devices have that safety snap on and off, and they do not lock purposely so that you can, in an emergency situation, you're going to come off the handlebars. You have good control, but at some point they're going to release so you don't get hurt. So one other thing interesting that we have in talking about mountain biking is, and I don't believe I have one here, but it's called the enter joint. So in the upper right-hand corner of this particular slide, upper left-hand corner, excuse me, is an elbow, and the elbow is a shock-absorbing elbow. And it came with an interesting story. A company called Advanced Arm Dynamics approached me many, many years ago, and they had a patient, a consumer who wanted to mountain bike, and he was missing his arm above the elbow. And they wanted something that would be a shock-absorbing type of elbow. And people had experimented with different kind of rock shocks built into the prosthesis and things like that. They hadn't been that effective. So I conceived of, and we wound up patenting a device called the enter joint. And the enter joint's actually an isolation joint. So what it is, it has an elastic polymer on the inside, and it separates the humeral component of the prosthesis from the distal component of the prosthesis with a shock-absorbing material. So you could put a terminal device on the end of it, whatever you might want, but what happens is that you have a flexible, energy-resilient elbow, shock-absorbing elbow that not only absorbs energy flexing but also extending. So you can imagine like an elastomer elbow that's adjustable for angular deviation. You can lock it at any position you want. Then once it's locked in, it absorbs all of the energy and shock you have from biking. And it's become very popular. We're in the process of actually designing a smaller version of it for pediatrics and for teenagers and such. So other kinds of activities that people enjoy doing, certainly, and we get into water sports like kayaking and canoeing. Another interesting story, Walter Reed Hospital approached us a long time ago, probably going back 20 years, and we had a lot of soldiers coming back from the Middle East and hurt with amputation, upper limb amputation. And so Walter Reed and Balboa Medical Center, Naval Medical Center in San Diego, and BAMC, Brooks Army Medical Center, all developed rehabilitation programs for their soldiers that would include kayaking and firearms practice and training. And they got people into pools. They wanted them to develop. Kayaking is a great upper body exercise. There was no device out there really for kayaking that was kayak specific. So we took on that challenge and we developed a device which we call the Hammerhead. And the Hammerhead is a kayak specific terminal device. It's been redesigned now into additive manufacturing, but it's designed, you can see it in the back. It's on the screen behind us, there's two versions. One is the older one, and this is the newer additive version. It goes on like this, and imagine I would put a kayak paddle into this, and I pull it around, and I simply snap onto the kayak paddle. So it gives me the ability to pop on and off the paddle. It's got a sort of a safety release that way, but the strap itself is elastic. It's very flexible, so it conforms nicely to slightly different paddle diameters, although most are pretty consistent. And it's been great, but this has been used for some crossover purposes as well. I think you've had people that maybe use it for lightweight dumbbells and exercise and things like that.
Yep, different exercises, but even heavy landscaping equipment, tools that you carry, people will hold on to it with the kayak device and be able to operate.
So the other thing Walter Reed came back with us to us with was that they wanted to be able to handle some long guns like M platform weapons like M16s, etc. Well, that was a little bit spooky in developing devices for handling firearms, and our emphasis was just to really want to focus on the safety aspects of it. And what they conveyed to us is they wanted to be able to have a person who had a hand absence have a prosthetics device that would been able to fit on a gun without modifying the gun at all. That was really important, but be able to give them the security of pulling it into their shoulder safely so they could not only fire at level, but they could fire above the level of their shoulders. And be able to control the gun while doing that. And so we conceived of the lamprey, which is a flexible rubber type of clamp that has an adjustable ball socket, snaps on and off the firearm easily, but provides the ability to handle a firearm very, very safely. And it's been used successfully not only for people coming out of the military, veterans and soldiers and such, but it's been used widely for people with sporting arms, wanting to hunt, wanting to pheasant hunt, target shoot, waterfowl hunt, whatever it might be, but for shooting, target shooting as a recreation, and also for certain hunting
and
applications.
even competitions.
Competitions as
yeah,
well.
We've had people in competition.
And on the bottom right-hand part of your screen that you can see is also another device that Texas Assistive Device created that I wanted to mention and show you. It's called a tool cradle, and again, it fits onto a standard prosthesis or fits their own custom system of mounting. Skiing, well, we're here in Colorado. Skiing season is almost done this year, but skiing has been a popular activity for many years, and there've only been a few efforts made to make ski devices in the past. Many people ski with one pole if they have one hand, or they don't ski with poles at all. But if you want to ski with a lot more control, especially Nordic skiing, which requires upper body propulsion, having a terminal device to help you is a big deal and makes a big difference. So we've conceived of, and what we build now called the Ski Trek. It combines not only the ability to handle a ski pole, but trekking poles, which have become a lot more popular. And it's as you can see in the pictures behind me, and I don't believe I have one here to show you. It's designed to be cable operated. So just in the way that I manipulate my thumb when I move forward, I can pull the pole forward. Okay. So it gives you the ability to actually plant the pole, lift the pole out, plant it down, and then relax. And it can be used with a cable, or it can be used passively without a cable. Have you used one of the ski devices in the past?
I used a downhill one in a similar way, just to hold poles while I'm snowshoeing or cross country.
Okay.
But I think I want to try that ski track.
So what Deb is talking about is another device called the downhill racer. This is a lot simpler device. It doesn't have a real mechanism in it. It's designed primarily to snap on and off the ski pole. You can see how flexible it is. It's designed to grip on hard because it takes a lot of load, but under a fall, it's actually designed to pop off the pole, and it's designed that the pole will always be on the outbound side. So the little downhill racer has both a right and left hand version. This is the right hand version, so that the pole used on the right arm would go out and away from your midline, so you wouldn't worry about injuring yourself on the pole when it releases. Excellent story, another good story. Lovely lady named Audrey Crowley. Her dad approached me. We're going back 6 or 7 years at least. I met her when she was about 8 years old, and her dad wanted a ski-specific device that wasn't nearly as complicated or heavy as our Ski Trek device. Now, you have a very short forearm. Audrey has a very short forearm, so she doesn't have a lot of support on a prosthesis. So having something that was very lightweight yet controllable was very important for her. So we conceived of and started to develop what became the downhill racer. And the best part of the story is Audrey, like a lot of little kids that we've known and people that you've known, yourself included, have a lot of who are born with a congenital hand absence, or born with a hand absence, are people who are achievers. They achieve things, and they do very well in life. Well, Audrey wants to become an Olympian skier, and she's on her way to do it. She is the youngest girl to be appointed to the Paralympic ski team at 13, and she got that. She was appointed last year. She was put on the team in 2023. So she's skiing on the team for the first time as the youngest Paralympian ever. Wow. So she's on her way. Michaela Schifrin, watch out. Fishing like golf actually is very popular.
Right.
There's different challenges. You can hold a rod with a prosthesis or your normal hand. You can reel with your prosthesis. And depending on what kind of fishing you're doing, whether it be spin fishing or casting or fly fishing, there's different ways to approach it, and there's different challenges. I prefer myself to hold a rod in my functional hand and reel with my prosthesis. That's the way I like to do it. Because what you have to realize with fishing, and there have been some very specific devices you can see on the screen behind me, devices that the one in the right-hand side of the screen were adapters that fit onto a fishing reel. The downside to something that's very specific, like a reel adapter, is that you're fishing and it's good for reeling, but if you catch a fish, now you've got something on your arm that's good for reeling, but not very good for handling the fish or changing lures or handling a net. So with fishing, as nice as it is to have a custom little adapter, there are downsides because it's over specific. It's too specific for all the other things that you might want to do while you're fishing. So I prefer, again, try to use the rod in your right hand if it's an option, and then reel with your prosthesis, whatever the prosthesis may be. A voluntary closing device is very good for that because you can control the force and hold on to that reel. You can pad the reel handles with rubber. There's a lot of ways to solve it. So these are some examples behind you of different ways to approach it. The device at the center bottom is another one by Texas Assistive Devices that has a lot of adjustment, angular adjustment to it, that actually is a reel adapter, so it fits on the reel handle itself for those people who need that kind of function.
I think one of the most important things to think about with these different devices is that even though they're intended for use a different way, we all learn and employ activities in different ways. Certain methods that we use will feel more natural than others. So to test that out and trial it and realize that there's not always just one way to accomplish a task, and oftentimes there's more than one right way. It's not a matter of always being right or wrong. It's about what works best for us as individuals.
So what we have up behind us on the slide on the screen now is, some alternatives. People who have had maybe much higher level or much more involved, missing an entire arm when they don't have an option to use a prosthesis. There's ways of solving that. So they have electric fishing reels. One of those illustrated there, and they have an ability that one of the gentlemen developed his own platform attached, be able to attach the rod right to his torso so that he could control the rod, have the rod stabilized and held, and then also be able to reel with his other hand. So as Deb was suggesting, there's lots of ways to solve some of these things. You just have to have a little bit of ingenuity and then have an ability to fabricate some things. But a lot of neat situations or opportunities out there if you keep your mind open.
Jump roping. So, way back in the day before a jump rope adapter existed, I had to tie one end of the jump rope onto a doorknob or something and jump rope that way, which was kind of limiting. First of all, if I didn't have a door or something to tie onto, that was a problem. And if it wasn't the right height, that was also a problem. Oftentimes by a door, to access the doorknob, there's also a step, and that is totally the wrong place to jump rope. But a device like this is great because it's got a pivot in it. The way it interfaces into the wrist of the prosthesis, it'll swivel so that you can turn.
Replicates the biomechanics you need.
Correct. So I find that really helpful. Plus, I like the material of the skip rope.
Yeah, these were high-performance skip ropes. We focused when we decided to design one of these. We had some consumers interested in skip roping, and there's actually skip roping competitions, as you might imagine. And so we got high-performance skip ropes, and then developed a device that would perform with those. And they're available. They're very inexpensive, and it's a great exercise. Archery has been one of my favorite things in sports activities for a long time. I've used a regular device, a voluntary closing device, to hold onto the bow handle. You can see it in one of the pictures behind you. I've modified my bows to have different alternative kind of handles. But then we developed a device called the Ishi, and that's shown in that upper left-hand corner of the screen. And it was developed for this little boy in the bottom of the bottom, Benno Chow. And Benno lives in Colorado at the time, and this is a picture of him when he was quite young. But his dad came and he wanted an archery-specific device. And so we conceived of just a little rubber clamp kind of system, kind of a mini multi-D is what it is. And it was designed specifically for archery because in archery there are hand-eye coordination aspects to it. And when you shoot a bow and arrow, you want the bow to slightly rotate to be in alignment with your eye. You don't want it to be held in line with your center line of your prosthesis. You want it to rotate. So having a knowledge about archery myself, we developed this very simple, inexpensive but very functional device, and we built it in a couple models. So even adults shooting very high-powered bows can buy the higher-end model, and it simply clasps around. It can be used with a traditional type of bow, long bows or recurves. It can be used with more popular compound bows, and it's actually designed to grasp onto any kind of a pistol grip. So you could ratchet it around a pistol grip as well, and it's got a little ratchet system on it, and it performs and gives you the ability to support a bow and shoot an arrow with real accuracy.
It's also the kind of device that you can use for many other functional kinds of activities where you would be holding on to a tool or a utensil. So you can think about, what is it like to be blow drying your hair? I don't know if you do that.
Nope.
Nope, didn't think so. But I have to, and holding the hair dryer in the Ishi makes it so much easier because the Ishi itself is lightweight, and I can hold it up here, be blow drying my hair while my other hand is managing a brush or whatever tool I need to use. And I've seen people even use it to hold a hammer or other small tool that's a household kind of.
That, and it's actually been used a lot for holding a fishing rod. For those people who want to hold a fishing rod with their prosthesis, the Ishi, because it sizes itself in diameter, it can clamp down on a wide variety of cylindrical type shapes. And so the Ishi has also been used for fishing and for holding a fishing rod. And some other archery devices, the one in the upper left-hand corner, a device made by Texas Assistive Devices. So if you have a prosthesis, depending on your eye dominance, you want to use your prosthesis for holding onto the bowstring, then you need a bowstring adapter. And so that's what this is. Texas Assistive Devices makes a bowstring adapter. You can clip onto the bow, pull back with your prosthesis, and that little pink stem or finger that you see in the picture is actually used so you can push it against your cheek to release the bowstring. And there's been a lot of the fellow that developed it is in the center top photo, Ron Farquharson, he was the inventor of that device, and he was the one who started Texas Assistive Devices. Hockey is a very popular sport as well. We've developed different kinds of hockey devices that are out there that are available to you as a consumer. Some were called a slap shot, the ones that are in the upper left-hand corner of your screen, are the slap shot devices. And with hockey, there are nuances too. Whether you top hand hold a stick or whether you hold a stick down on the handle or the shaft will dictate what kind of a device you need, and they have to be designed slightly differently to do that. So you see some examples here of what those are. The device in the middle, this is called a helix, and I'm going to let Deb talk a little bit about this. It can be used for hockey. It was initially conceived of and to be used for hockey. It was designed by an industrial design student out of Denver, and we actually did a design patent on it, but Deb's used it for a variety of other things as well.
Yeah, being an occupational therapist, I'm always looking at functional benefit and how else can we use something and get greater value out of it. And when Bob gave me one of these devices, I don't play hockey, so I didn't use it for hockey, but I did use it for other things. I tried it out with even sweeping and just lacing my broom handle through it. And it offered me an interesting perspective because I could tilt it toward midline, which meant I was able to bring my tool closer to use. So then I thought, this would be great for gardening because I can use this on my prosthesis side, obviously, and use it to hold that little 3-pronged tool that you scrape at the dirt with and loosen up the dirt. and then be using my left hand to actually dig. So I could loosen the dirt on the right side by holding it with this, and then dig with the left, plant my thing, my little flower, and then move on to the next one.
I'm gonna put this on and demonstrate it because it's it could be difficult to understand how this actually works. This is not rigid. The helix is a very, very flexible rubber material, and it's unique that way. So how do you engage things to it? You simply pop them in like that.
Yep.
And it's very flexible. It feels a lot like your human wrist. And this is on a little mini lacrosse stick for demonstration, but it simply can be popped on and off pretty easily. Again, you just simply weave it in, snap it on, and it can snap on and around. And it slides up and down, and yet when you load it, it grabs on because of its elastic characteristics. So it was a really fun project, and it was conceived of by an industrial design student from the school in Denver. And we took it and took it into it took us about a year to get it figured out completely to make it really functional, but we were able to put it out and get it so to make it into a functional little product.
Yeah, that material is also shock absorbing, so it takes the impact of some of your digging or tool use.
And one other device you see up there, what is the elongated black elastomer type of thing, is called a power play. And so the power play was conceived strictly for end stick handling. The power play is designed, has a lot of elasticity to it, and you can see in the pictures behind me how much range of motion it has. So you modify your hockey stick, you can cut it off a little shorter, it force fits right into the end of the power play, and it provides you really a dynamic, very highly functional prosthetics device, but for end stick handling only. This slide is a little bit redundant, but it illustrates some of the things that Deb was talking about in the applications that she had for handling garden tools. One of those pictures up there shows it for using, I think they call it kendo. It's a martial arts that uses a wand or staff for protection, and it also fits onto, we've used it with a cue stick. So great. For a person who wants to handle a cue stick, with their prosthesis, it has the right angle and flexibility to do that as well.
Yeah, I've even used it to lace the hose through. Yeah. And when I'm gardening different areas of my yard, I don't want to trip over the hose, so I can move it out of the way.
Hose management.
Hose management and electric cord management when I'm vacuuming. Yeah. It's similar concepts, but we can use it in different ways. It's all functional.
The multi-D. The multi-D stands for multi-diameter, multi-duty. You've used the multi-D quite a bit. It's a very good example of a crossover type device. It wasn't designed for anything specific other than to handle adjustable diameter cylinders, handles, and things
heavier
like that.
Tools. It's great for wielding a heavier hammer. And using it that way too.
Yeah, so these are just some examples behind us. The multi-D is a ratchet control device, pretty heavy duty. I think the ratchet strap handled upwards of 200 pounds or more, and so it can be used for a variety of different kinds of things. The one thing I wouldn't recommend it used for is you don't want to ratchet around the handlebars or things like that with a device like this. You don't want to be locked onto something. So I wanted to talk a little bit as we start to close out the session here about 3D printing. And its applications, and what we're trying to do is to take a lot of these activity-specific devices that in many cases have required a lot of different kind of manufacturing techniques, might be machining aluminum and polymer fabrication or molding. And with the advent of 3D printing and what they call additive manufacturing and the expansion of the materials available to us, a lot of the products that we're showing you today, they're evolving. They're evolving in their design, they're evolving, they're going to have the same kind of function or improved function, but they're going to be made differently because of the advent of the ability to use manufacturing techniques that are evolving here in the 21st century. So you have a lot to look forward to.
Yeah, it can make some of our devices lighter or even stronger, or certainly as strong as what they already are.
And be able to stylize them in ways that we haven't been able to do with just normal manufacturing techniques, just to add a little class or pizzazz to them, whatever it might be. And these are some examples behind us of some of the things we've been able to do.
And even the new mini swinger, like that's an exciting development. And all of this has really led to further expansion of the crossover devices, which are in the catalog. So being able to come up with other values, other functions for the devices just improves our own use and even our visibility, because we might use a device in an environment that is new, where people have never seen that device, and we get to explain to them what it is. It's also a great way to justify and help get reimbursement, because prosthetic technology costs money. We have insurance for a reason, but oftentimes insurance puts limits or caps on what we can have.
So the future's bright, and we're excited for you. We're excited for where prosthetics is going to go. These activity-specific prostheses will continue to help you provide you an ability to just do more things competitively and live fuller lives. So we want to thank you for being with us again today, and we'll be back to see you in another episode.
Stay tuned.